Hello everyone, today we're going to learn about trigonometric functions ratio and how we can solve a right triangle function. Trigonometric functions can make life or can make our life easier by finding the length of the side, length of let's say the angle measurements, like this example here. Let me draw you a triangle, right angle triangle. So let's say we have this right angle triangle. This one is 90 degree. Okay, and let's say we have this one is A, this one is C, this one is B. Now, if you look to this right triangles, what is the trigonometric? So what is the trigonometric? Trigonometric is the sine, cosine, tangent. We have three types of trigonometric: sine and, sorry, let me write sine. Okay, so we have three trigonometric. The first one is sine, the second one is cosine, the last one is tangent. Okay, tangent, or let's say it tangent, like this. So now we have a three trigonometric. The first one, sine, cosine, tangent. Now, what is the sine, cosine, tangent? So sine, cosine, tangent is trigonometric functions that can help us to find the sides here. As you can see here, first thing, let me look to this triangle. Let's say we have this angle, and let's give this angle name as theta. Now, if this one theta, okay, that's mean if I need to find this angle measurement, I have to use one of these. So I have to give this angle name for everyone. So it will be sine theta, cosine theta, tangent theta. So I can find this angle by one of these. All of these can give me same measurement of angle if I use any one of these. Now, how can I use them? The rules or the ratio of the sine is written as op over hypotenuse. Okay, the cosine is edge over hypotenuse. The tangent is op over adjacent. Okay, what is op, what's edge, what's hyp? As we can see here, okay, let me write them here. Op means opposite. Okay, opposite, that's fine. Okay, then we have edge, which is adjacent. Okay, and hyp, which is hypotenuse. Okay, hypotenuse, it's fine. You under hypotenuse. Here is hypotenuse. Okay, so as you can see here, opposite, adjacent, hypotenuse. Now, what is the opposite, adjacent, hypotenuse? Related to what? What these three things related to which? What do you mean? To relate to what thing? Okay, it's all of these is related to the theta that we need to find, which means is related to this theta here. That's mean if I ask you, okay, if I said sine theta opposite over hypotenuse, that's mean this side here, what's the opposite side of theta? The opposite side is this one here. This one is the opposite side. So the opposite side, so let's call this side is equal small b, let's give it small b. Okay, and hypotenuse, we know that the longest side in every the right triangle called the hypotenuse. So this one called the hypotenuse. Now, if I need to find the sine theta, okay, according to my triangle, so sine theta is b over the hypotenuse. That's what I wrote here. Now, the cosine, from its name, it's called what? Adjacent over hypotenuse. So this angle, we know this one is the hypotenuse, okay, and this one is the opposite of the theta. Now, which side is the adjacent? For sure is the remain side. So this one is the adjacent, for this side is the adjacent. So let's call this one is a small a. So now, what's the cosine theta? Cosine theta is small a over the hypotenuse. Okay, so every time I will say hypotenuse, no. Let's change hypotenuse word and write a small letter as the Pythagorean theorem. Do you remember the Pythagorean theorem when you said c squared plus equal a squared plus b squared? So we have this is a, this b. So that's for sure this one will be small c. So now let me change the hypotenuse, okay, from the sine and cosine, and let me write a small c. and small c. So the same thing for the tangent. The tangent theta will be opposite over adjacent. So the opposite of this one is small b. So this side is the opposite over the tangent adjacent, which is this side here, over small a. So these are the three trigonometric main trigonometric that we are going to learn. Okay, and this is how we can find them. Now we have other three trigonometric, which is we call them, let's say, other three trigonometric. So the first one is the reciprocal or the inverse or the reciprocal for the sine, which is we call it cosecant. Okay, and we have the reciprocal for the cosine, we call it secant, and we have the reciprocal for the tangent, we call it cotangent. Okay, now if I need to find the theta for all of this, same thing. So I can use cosecant theta, and I can use secant theta, and I can cotangent theta. The only things that I need to know is the ratio. What's the ratio? If I know the ratio, it's easy to understand, which means the ratio of the cosecant, is the sine, okay, 1 over sine. So 1 over sine theta. Okay, so the cosecant, because it's the reciprocal of the sine, it's 1 over sine theta. Same thing for the secant. Secant is 1 over cosine theta. Cotangent is the reciprocal for the tangent, so we can say 1 over tangent theta. Okay, so if you look here to the reciprocal, we can let's say summarize this one, or we can write the rule of this one, because this one is the reciprocal. Reciprocal means you are flipping denominator and numerator, numerator and the denominator. So I can rewrite this one to become as. Now, what's the ratio of the cosecant? The ratio of the cosecant theta, just flip this, which is hypotenuse over opposite. Okay, the secant theta is the adjacent, sorry, it should be the hypotenuse opposite this, so it will be hypotenuse over adjacent. Okay, the cotangent, the reciprocal of the tan, adjacent, so tan theta is adjacent over opposite. So these are the trigonometric functions. Now if I need to use this trigonometric to find my ratio, let me write it here. So I know that hypotenuse over opposite, so cosecant theta is hypotenuse, which is c over b, and the secant is the hypotenuse over adjacent, so secant theta is c over a, and the tangent, which is opposite over, so cotangent theta is the opposite, which is adjacent over opposite. Okay, oh sorry, here I have to change this one, not tangent, it's cotangent, sorry, cotangent theta. So now the cotangent theta is adjacent over opposite, which is cotangent adjacent over opposite. So as you can see, so this is the trigonometric ratio and how we can find the theta of this one. If I change the theta, okay, so let's say I have this angle here. Okay, so this angle, let's call this angle to its letter. So let's say this one is angle A. Now if I need to find angle A, what's the thing change will happen to this trigonometric? The only thing will happen here is the side. So now if I ask you what's the opposite side for A, the opposite side for A should be this one, small a. Now what is the opposite, the adjacent side for A? The adjacent side should be the B, which is this one. And hypotenuse always still say, which is the longest side. We know hypotenuse always longest side. Now if I ask you what is sine A? Sine A is A over C, sorry, say A, opposite over hypotenuse, A over C. What's cosine A? Okay, what is cosine A? Cosine A is the adjacent, which is B over hypotenuse, which is C. What's the tangent A? Tangent A is opposite over, which is A over B. Okay, what's the cosecant? Cosecant A. It's the reciprocal for the sine, which is C over A. What's the secant A? Secant A, it should be the reciprocal for the cosine, C over B. And what is the cotangent? Okay, cotangent A. Cotangent A is the reciprocal for the tan, which is B over A. So these now are my trigonometric functions, okay, and this is what we learn now about them. So if I put a line, so these are the ratio, these are without the ratio, and these are the answers. Okay, so this is the trigonometric ratio. I hope you understand the trigonometric ratio very well. Inshallah, next time we're going to learn how about we can solve some questions, how we can use this ratio and some other questions. Have a good day. Bye-bye.